me talk about section 10.2.3. So an example of target tracking. So we have used this example several times in chapter 3, chapter 4, chapter 5, and chapter 6. So this is a simplified version of the radar tracking system. So the state X, it contains the position and velocity. So it's a discrete time system. So H is a sampling period. So C and it are process noise and the measurement noise respectively. So V is a measurement. It only measure the position. So the basic assumption about the C and it had been given in 10.2. And here we only assume the sampling period has uncertainty in an interval. That's the normal value is 0.01, but with 10% modeling error, then its range is between 0.009 and 0.011. Then we assume the initial state had the mean value 1, and covariance matrix 0.5. Then the process noise has covariance matrix 0.1, and measurement noise had variance 0.1. And you just apply the interval Kalman filter. So that will be here. Then I will use MATLAB's symbolic toolbox to show you how to do the calculation. So this is MATLAB symbolic toolbox. Let's go from here. So you define the symbols. So this is the H. Let me go back. So you define the symbol H, then the Q, then the R. Then you define the P matrix. It's symbolic matrix, a 2 by 2 real matrix. Then you want to make P symmetric. So you do this, then P is symmetric. So let me go here step by step. So after this step, we get P. I can show you what P looks like. You see symmetric, the P11, P12, P12, P22. So this is a Q. So Q is here. Then this is A matrix. So A matrix is 1H 101. Then the B matrix. B matrix is an identity matrix. So C is 10. So let's look at the equation. So M will be A transpose P, A P A transpose, B Q B transpose. See? So this is the M. M is A P A transpose plus B Q B transpose. If I run one step, so this is the M, but I can, if I compare to M here, it's very close, but we can further simplify. So we can simplify M. Then we can compare the value. So here is P22, so plus Q. So this, because it starts with 0, so this is the same. And here, so P12 plus P22H, so the P1, so the P12 plus P22H, because same here, P12 plus P22H. So here you can see we have the P22H square, then 2 times P12H, then P11 plus Q. Okay, so that's the M matrix. Now we see the G matrix. So G matrix will be just M times C transpose. So divide by C M C transpose plus R. So this is what G looks like. Then let's go back. To see, so this is the M12, M11 plus R. So this is G2. So this one you can simplify it. So that will be M11 plus M11R. So here's a 0. So that's the G matrix. Then last we have the P matrix. So P will be identity matrix minus G times C, then times M, then identity matrix minus G C transpose plus GR G transpose. So do here. So this is the P matrix. It's very complex, but I can simplify it. Then you can, when you look at it, become very simple. See, this is very complex. Then using MATLAB symbolic toolbox, so I can simplify it. Then we can compare it with the example here. So see this so if you still remember, so this is the G11. The G1 is M11, M11 plus R. Okay? So this is just R times G1. Then the G2 is M12 plus M11R. So here we have exactly R times G2, then R times G2 here. So this one is a little bit complex. Then let's do one more simplification. First, let's collect the term according to MI22. Then you know the MI22, you see it's simplified, okay? So it's simplified to this form. Then you still remember that the P22, if we compare here, so the M22, if I go here, so the M22 is P22 plus Q. If you compare here, we already have Q, okay? So we already have Q. So if we multiply this whole thing, okay? So by M11 plus R, okay? Then minus, so this is Q plus M22. Yeah, because we already have Q, so we're using M22, okay? You M22 multiply M11 plus R, it should be something inside this bracket, okay? Should be something inside, okay? So then we do the calculation. So then we're using the P22 to multiply M11 plus R minus M12 squared, okay? Then we do one more step. Then we expand it. Then we collect the term again, okay? According to P22. Now then we compare, you see exactly the same, okay? This is the P22, then P11 plus Q plus R, then minus P12 squared, okay? Then let's go back to see the formula again. So we define symbol xk and bk. Then the x hat will be a xk plus g bk minus c a xk. Okay. Then we run one more step. So we go back to compare the result. Then you see we have here's R times MK1 plus HMK2 plus MBK. I think here's a typo. It's not yk, it's a vk. Then divide here, I think it's another mistake. Okay, so let me correct it. So here should be vk, then here should be m11 plus r. Okay, so here's v. Okay, here's v. Okay, then you have the first expression. Then for second expression, I think let's use a different form. Okay, let's use this form. Then we can compare. So you have xk2. Then here we have plus minus is g2. Then here we have minus. Then we have plus xk1. So minus plus hk2. Then minus vk. Here yk, I think is another typo. It is vk. So here's the vk, just the measurement data. Then I will show you the simulation result. Okay. It will be here. Okay, let me finish this one. Yeah, then you can see, let's book comment. Okay, I think in one of the sentences it said, okay, these two boundaries encompass all possible optimal estimates. Okay, so if I can zoom, let me hide this. Then you can see just between the two. So the black line is the lower bound, the red line is upper bound. So the estimate is between the lower and upper bound. And also, like the comment earlier in this section, it said this bound could be very conservative. Okay, as time goes on, the bound will be larger and larger. Then there's one more problem about this approach, because when I increase the interval, okay, I'm not sure if you have wondered, because when you look at the two figures, so one figure only run about 350 seconds, then the other one run 900 seconds. Okay, so I think you may wonder why they only run 350 for the first state, then for the second state, it runs longer. Why they didn't choose the same time axis? Because the reason I think is because when you, let's say, increase the time interval from to 350 seconds, then it gives you some error. Okay, then this error comes from when you do the division. See, then it's from here, this line 93. When you do the division, okay, then you still remember the interval division. So the interval must not include the 0, but you cannot guarantee that, because for the interval multiplication, so if you have here, you have two interval multiplied together. It's not like two number multiplied together, all positive. But when you have two interval multiplied together, you cannot guarantee the interval does not contain 0. I think that's the main reason. If you doing the calculation, if you do the interval division, in sometime if the 0 is included, then you need to stop the calculation. Otherwise, it will not be accurate.